Hello everyone, welcome to Dr. Ravi's Academy. In today's class, you will be learning the condition for correct steering mechanism. So here, what is the essential requirement to have a correct steering mechanism? So that you will be understanding by means of a schematic diagram, and you will be arriving a condition for the correct steering mechanism. So let us consider a four-wheeler. And rear axle, you have two rear wheels, and let us say the front axle, where you have I am extending the velocity of the rear wheels will be forward. As you know that the essential requirement for the correct steering is you must have the instantaneous center of rotation, a single or unique instantaneous center of rotation for the all four wheels. So I am considering the four-wheeler is negotiating a left turn. LT indicates left turn, and I am erecting perpendicular to both the rear wheels. And here you have a stub axle, and on stub axle a wheel is mounted. Let us consider this is inner turning wheel, and let us extend this. On this you have outer turning wheel. Let us observe carefully. Here you are negotiating a left turn. So in order to have a left turn, all these four wheels, two inner wheels and two outer wheels, must rotate about a single instantaneous center of rotation, that is I. So that's what is exactly the essential requirement for the steering mechanism. So what happens if it rotates about a single instantaneous center? All four wheels will be undergoing pure rolling, that is required. And otherwise what happens? Skidding takes place. To avoid the skidding, to ensure that pure rolling, all four wheels, now the direction of the velocity of the front wheel is this, and you have erected a perpendicular, this is 90 degrees, this is 90 degrees, of course this is 90 degrees, and this is 90 degrees. As you know how to locate the instantaneous center of rotation. If you have four different points, let us assume that four wheels, if you erect the perpendiculars to the velocity vector, here the velocity vector is in this direction. The intersection of the perpendiculars to the velocity vector is known as instantaneous center of rotation. So you must have a unique instantaneous of rotation, that is I center, so that your four wheels will be undergoing pure rolling. Now let us extend this, and let us have this extension. The distance between the two pivots, I am denoting it by small w, and wheel base, the distance between the front axle and rear axle, I am denoting it by L. Right. Now let us consider this is P, Q, R and S. Let us consider these 4 points, and I am considering this point is T. Now you can write down a simple expression from triangle, from right angle triangle. Let us consider TIQ. From this right angle triangle, TIQ. TIQ. Write down the expression. This angle, let us consider it is angle theta. The inner turning angle is theta, and outer turning angle is phi. So let us write down the expression for the cot phi. Cot phi is nothing but it is adjacent side is TQ and opposite side is TI. Let us consider this is equation 1. And from right angle triangle, let us consider TIP. 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 From this, write down what is cot theta. Cot theta is equals to adjacent side is TP and opposite is TI. This is the opposite side. Now this you call it is equation 2. So equation 1 minus 2, let us write down cot phi minus cot theta is equals to TQ minus Tp divided by Ti. But you know that what is the Tq? This is Tq. Tq minus Tp is nothing but W. It is the distance between the two pivots of the front axle. Ti, this is nothing but wheel base, that is L, the distance between the two axles, front axle and rear axle. Now, you can conclude that the condition for the correct steering mechanism is cot phi minus cot theta is equals to W by L. So, this is the condition for correct steering mechanism. I think you understood this concept. Let us practice it. Thank you.